There's also an introductory exercise in Get to Know SEL. This is about program and SR, set, reset, flip-flop. But there's a little more to it that you could try by yourself too. Yeah, we can just move over here. So it's a program flip-flop that you could call here and call this one again in main. So we have a fbSrFlipFlop and has an fbFlipFlop2. So there are two kind of flip-flops. This is an SR and this one, the second one here is a little different. So you can use these names maybe. So here's the assignment, SR flip-flop. It's called fbSrFlipFlop. Why does it have to be an FB? Because it has static memory. Two inputs, these are not according to the naming convention that we are using. SNR and our output Q, because that's what you use in an SR flip-flop. We don't have a QN, the negative output, but you could have that too. So there's input sets the Q output to true and R resets it to false. When S and R inputs are simultaneous true, the output should be set to true, because S says that, okay, the set has priority. If it was R with priority, the flip-flop would be called RS flip-flop, whatever. When S and R inputs are simultaneous false, the output should be kept. The output should keep the last value as true or false, depending upon if it's set or reset. Work procedures. Make a function block, of course. You have to program this one. Declare inputs SNR output Q. They are Boolean. Write SR flip-flop functionality. Instance data block. IDB SR flip-flop. Program call to the function block instance, OBM main, via some programs, and test. By starting simulation, download programs, set instance block online. Yeah, so you can double click in the instance data block. There's a check, guys. And what do you get to know? Instance data block, function block that we have to write, an instance, data block, and project, if then, and if I think we have to use, and static output variable. So here are what could be in your function block. The first one, it's the first program we are writing. We have SR and Q output. The code should be something like this. So we have the pseudocode here. If reset input, if so, if set input, else if. Here, the last one, the set is winning if they are simultaneous true, and here the set is winning because if set is true, it's not going to execute this part. So, and then you can extend that and say, okay, as our flip-flop, there's a program element that we find in firmware anyways, but we can make a multifunctional flip-flop with a parameter type. So here we could make more to it, SR, and the type is true is SR and false is RS flip-flop and Q. And then we should only write to the output a single, only at the end of our program. So then we use a static one for the output. And we call this S static Boolean Q because it's related to this one. General purpose, yeah, and here is the type is set reset because the type is Boolean, so that would pretty much be if PT. I think that was true with SIR, and then do same code here. Else, as a Boolean, if it's not true, it has to be false, so we don't have to check else if false. It's else. RS, and then we just switch this set and reset, and also the false and true. So that is the assignment for this one. So, of course, what you have to here is to get to know is how to make a function block, a new function block. But then again, in the introductory, how to do this, you can, there's in the help files or whatever. So that was another introductory exercise, a real simple one, as simple as a get, basically an if statement. We will do some set and reset on an output. And there were two variants, one SR flip-flop, that was the assignment. Then we have an optional one where you say, okay, we use a parameter because what's an SR flip-flop today might be an RS flip-flop tomorrow. And then we can change a parameter online instead of changing the program or replacing the program elements. Of course, SR flip-flop and flip-flop like this, that's something we should try to avoid as much as possible. These memory elements here, they should maybe be hidden in final state machines, so we should try to look into that. At least try to use other ways of programming that so we can avoid SR flip-flop.